All right, we're going to graph a line with a y-intercept of 2 and an x-intercept of -3. We already did a little bit of this in part 1 of this video. And so when we're doing it in this part, it's just the same concept. We're going to go ahead and draw our axes in. Now, because I knew that I had these intercepts as they were, I didn't have to make any special concessions and put them like up in the left-hand corner or the right-hand corner. And so when I go ahead and graph these intercepts, I've got a y-intercept of 2, and so that's here. And an x-intercept of -3. See how I did that? And so when I connect these dots using a line, missed a little bit, but that's okay. I'll just move it down. I've got this line here, and then I'm going to just draw the arrowheads on. You see how easy that is? When you have the intercepts, you don't have to make a whole table. You just simply use the intercepts that you have and connect the two dots. It's pretty simple, okay? And so here's one for you to do, except you're going to find the intercepts and then graph the line. So if you want to, go ahead and pause it right now. After the pause, I am going to solve the problem, and I'll show you how to do it step by step. But if you want to try it on your own, I would strongly encourage you to pause it right now and try it on your own. All right, we're back from the pause. I'm going to label x-intercept, y-intercept. Okay? And once again, when we substitute these values in, I'm going to let y equal 0. So 0 equals 2 times x minus 10. So 10 equals, let me do it step by step for you so you don't lose me. Plus 10, plus 10. So I have 10 is equal to 2x. So if I divide by 2, 5 is equal to x. Okay, I've got my x-intercept. For my y-intercept, I'm going to let x equal 0. And so when I put in y equals 2 times 0 minus 10, I get y equals minus 10. Okay, I've got my two intercepts. Now, once again, I'm going to put in my axes. And I know that I'm going to need y equals 10, but that's way up at the top. And x equals 5, I'm going to need to give myself plenty of space. Shouldn't be a problem, though. I've got plenty of space here, plenty of space there. And so when I go to graph this, I'm going to use 5 for x. So that's over here, 1. Remember, this is x. This is y. Okay? Now, 1, 2, 3, 4, 5. That's x equals 5, and y equals 10 is up here. 1, 2, 3, 4, 6, 7, 8, 9, 10. Sorry, it's -10. Gosh. See, sometimes even math teachers make mistakes. I was wondering why that looked like that. Okay, let's move this up because we're going to need -10. And so you'll notice I need -10, so I'm going to put this sort of near the top. And so let's try this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is -10. 1, 2, 3, 4. That's better. So now when we graph this, we've got an idea of what's going on here. And I connect the dots. And look at that. We have a graph going up and to the right, and as you'll remember, that's a positive correlation because our slope is positive. Okay, so I found the x and y intercepts, and I graphed it using the intercepts. Now, Dina runs and walks with her dog on a trail that is 8 miles long. She can run 4 miles per hour and walk 2 miles per hour. We're going to graph the equation 4x plus 2y is equal to 8, where x is the number of hours she runs, and y is the number of hours that she walks. What do the intercepts represent? Okay, so we're going to graph this function. So we're going to graph 4x plus 2y is equal to 8. What I'm going to do right off the bat is I'm going to solve for y because I wanted it to get it in y equals mx plus b. So I'm going to subtract 4x. So I've got 2y equals -4x plus 8. Okay? And then I'm going to divide by 2 on both sides. So y equals negative 2x plus 4. Now, I need to find my x and my y-intercept. X x-intercept, y-intercept. So this is where y equals 0. This is where x equals 0. And so when I solve for these two things, if y is equal to 0, 0 equals 2 minus 2x. Let me rewrite. I'm trying to smash it in too much. Y equals negative 2x plus 4. So 0 equals negative 2x plus 4. So if I subtract 4 from both sides, I've got negative 4 equals negative 2x, and I'll divide by negative 2. I'll divide by negative 2. Remember, if I'm going too fast for you, just slow it down. Pause it. Let the video marinate while you take notes. X is equal to 2. Okay? So my x-intercept is x equals negative 2. Sorry, positive 2. X equals 2. Now, y-intercept is when x is equal to 0. So y is equal to negative 2 times 0 plus 4. So y is equal to 4. Okay, now I've got my x and y intercept. I'm going to go ahead and graph this. And when I graph this, I've got my axes in. And I'll just put in my points like we've done before. X is equal to 2. Y is equal to 4. 1, 2, 3, 4. Okay? And when I connect the dots, I notice that I've got a negative correlation here. Now, the problem asks, what do the x and the y intercepts represent? Well, if x is the number of hours she runs, so this here is runs, and this is walks, x is going to represent the running part. So this x-intercept is where she runs 0 hours. This is going to be where she walks 0 hours, right? What is it actually saying? The x-intercept is where y equals 0. So it should be switched. We want to say that the x-intercept is run 0 hours. But in reality, because of what we set equal to 0, where the x-intercept is, right here, that's where y was equal to 0. That's where the numbers of hours she walks is equal to 0. This is where she runs. And it's equal to 0. These are hours. Okay? Those are what the intercepts mean. We're going to work a little bit more with this tomorrow. But go ahead and try this. We'll see you tomorrow.